Good morning all. Today we can discuss about digital signature. So what do you mean by digital signature? Digital signature is a signature that is analog to handwritten signature and it provides some security capabilities. Okay, actually this digital signature which provides the authentication of two parties or the authentication of contents, authentication of date and time. So the message authentication actually it protects the two parties who exchange messages from any other third party. Okay, but it does not protect the two parties against each other. It only protects from a third party. So for that purpose, we are using digital signature. Actually, it is an authentication mechanism. Okay, so we are creating the signature by taking the hash of a messages and encrypting the messages with creator's private key. Okay, so signature guarantees the source and integrity of the messages. Okay, so the digital signature is analogous to handwritten signature and it is used for authenticating the message, authenticating the source and to verify the integrity of the message. So what are the properties of this digital signature? So by using the digital signature, we can verify the author, that means the source of the message, date and time of the signature. Also, it can authenticate the contents at the time of signature. Actually, this will be happen by using a third parties to resolve disputes. So we are using some third parties to verify this signature. Okay, so these are the three properties of a digital signature. We must verify the author, date and time of the signature. Also, we can authenticate the contents of the messages and it can be verifiable by third parties to resolve some disputes. So the requirements of the digital signature. Actually, the signature is depend upon the message being signed, and for creating a signature for a particular messages, we need some unique information to the center. Also, it is relatively easy to produce that digital signature and it is easily recognizable and verifiable. It must be computationally infeasible to forge a digital signature. It must be practical to retain a copy of the digital signature in storage. So these are the requirements of a digital signature. Okay, the signature is actually depends upon the messages. Also, it must be easily producible, easily verifiable, easily recognizable. We need some unique information of the center to create signature, and it must be computationally infeasible to forge a digital signature. It must be practically to retain a copy of the digital signature in storage. These are the requirements of the digital signature algorithm or digital signature. So നമ്മളിപ്പോൾ പഠിക്കാൻ പോകുന്നത് digital signature ആണ്. So digital signature, it is actually analogous to handwritten signature. Actually, it is used for message authentication purpose. There are two categories of digital signature. One is direct digital signature and another one is arbitrated digital signature. So there are two mechanisms for making a signature of digital signature of a message by using direct digital signature and by using arbitrated digital signature. So first one, direct digital signature. It actually involves the communication parties only. There is no third party verification is here. The digital signature can be formed by two ways. We can encrypt the entire messages by using center's private key to generate a digital signature, Also, we can create the hash of a messages and then encrypt. So these are the two possible methods for direct digital signature mechanism. That means we can we can encrypt the entire messages with the sender's private key, or we can encrypt the hash code for messages with the sender's private key. So these are the two mechanisms that is used in direct digital signature. In case of any disputes, in some cases third parties can verify, but the direct digital signature is in between the two communicating parties only. The sender can send the data with its digital signature to the receiver, and the receiver can verify the authenticity of that messages, date, time, author, etc. So that is actually direct digital signature. But it has some weakness. To deny a messages, the sender claims that his private key was stolen, and for this weakness, we have to need a solution. That solution is actually a timestamp and prompt reporting, and that is the two mechanism for this private key stolen problem. And this is the digital signature, direct digital signature model. You can see in the figure, we have two communicating parties, that is Bob and Alice. So at the center side, we have an original messages M. By using the sender's private key, that is Bob's private key, we can create a Bob's signature or the digital signature by using some digital signature generation algorithm. Okay, after getting this digital signature or Bob's signature, what we are doing is we have original messages and we can append the signature with the messages. Okay, and that will be sent to the receiver side. At the receiver side, what we are going to do is we have Bob's public key, that means sender's public key. And by using the sender's public key, we are taking the messages and we are creating some signature, digital signature is creating, and it is compared with actually the S. S is the digital signature of the Bob. So we are comparing the signature at the receiver side. For that, we are using a digital signature verification algorithm. Okay, at the center side, we are using a digital signature generation algorithm. At the receiver side, we are using a digital signature verification algorithm. This is actually a direct digital signature mechanism because only the two parties are involved here. Sender is there, also receiver is there. Sender sends the messages with the digital signature, but at the receiver side, you can take the original messages and you can create the signature corresponds to the Bob, and you can compare with the appended signature with the generated signature at the receiver side by using a digital signature verification algorithm. Okay, so this is the structure of direct digital signature mechanism. So this is the explanation. And if we are using some hash properties or hash values for this digital signature mechanism, we have an original messages at the center side, that is message M, and by using some cryptographic hash functions, we are creating some hash value. Then we are using some encryption method by using Bob's private key for the encryption of this hash value to produce a Bob's signature. You can see in the figure, message M is the we are creating a hash value by using a hash function, and that hash is encrypted by using Bob's private keys to produce the signature of a Bob. And that will be sent to the receiver, Alice side. So at Alice side, what we are doing is how the verification is happening is we have a messages that is coming from the Bob, and by using again we are using a cryptographic hash function to produce the hash value. Then you are receive the signature by signature is encrypted one, so we are using a decryption process by using Bob's public key. Then we are producing the hash. Actually, hash is encrypted at the center side. So if we are doing a decryption at the receiver side, what we are getting is the hash value. So from the hash value, we cannot create the original message because the hash is not reversible. So we are actually comparing the hash values. that is getting from the original messages and that is getting from the decryption of the signature. You can compare. If they are equal, the authenticity is verified. Okay, so this is the procedure that has happened in direct to digital signature mechanism. If you are using the encryption on messages, and if you are using the encryption of the hash value that is created from the original message. Next mechanism is arbitrated digital signature. Actually, in direct digital signature, you have the communication party, sender and the receiver. But in arbitrated digital signature, you have an intermediate component, or the third party is what we are calling the third party is the arbiter. So actually arbiter, what is the function of the arbiter means it is used for the verification purpose. In direct digital signature, you can see that the receiver itself is doing the verification process, but here the arbiter is doing the verification. So the third party involves in arbitrated digital signature. Okay. So in arbitrated digital signature, you have three mechanisms. One is by using conventional encryption, and the arbiter sees the messages. And the second mechanism is the conventional encryption, in which the arbiter does not see the messages. And the third mechanism is by using the public key encryption. Arbiter does not see the messages. So, നമ്മൾ ഡിജിറ്റൽ സിഗ്നേച്ചർ മെക്കാനിസം ആണ് പഠിക്കുന്നത്. ഡിജിറ്റൽ സിഗ്നേച്ചർ നമ്മുടെ മെസ്സേജ് ഓത്തൻറ്റിക്കേഷൻ, ഓത്തർ കറക്റ്റ് ആണോ, മെസ്സേജ് കണ്ടന്റ് അതിൻ്റെ ഓത്തൻറ്റിസിറ്റി, ഡേറ്റ് ആൻഡ് ടൈം ഒക്കെ പ്രൊവൈഡ് ചെയ്യാൻ വേണ്ടിയിട്ടാണ് നമ്മൾ ഡിജിറ്റൽ സിഗ്നേച്ചർ മെക്കാനിസം യൂസ് ചെയ്യുന്നത്. സോ ശരിക്കും അതൊരു ഹാൻഡ് റിട്ടൺ സിഗ്നേച്ചറിന് ഈക്വൽ ആണ്, ബട്ട് ഇറ്റ് ഈസ് എ ബിറ്റ് പാറ്റേൺ ദാറ്റ് ഈസ് ക്രിയേറ്റഡ് ഫ്രം ദ മെസ്സേജ് ഇറ്റ് സെൽഫ്. സോ എങ്ങനെയാണ് നമ്മൾ രണ്ട് മെക്കാനിസം നമ്മൾ ഉപയോഗിക്കുന്നുണ്ട്, ഡയറക്റ്റ് ഡിജിറ്റൽ സിഗ്നേച്ചറും ആർബിട്രേറ്റഡ് ഡിജിറ്റൽ സിഗ്നേച്ചറും. ഡയറക്റ്റ് ഡിജിറ്റൽ സിഗ്നേച്ചർ ആണെങ്കിൽ സെൻറ്ററും റിസീവറും മാത്രം, റിസീവറാണ് വെരിഫിക്കേഷൻ നടത്തുന്നത്. അപ്പോൾ നമുക്ക് സെൻറ്റർ മെസ്സേജ് എടുത്തു, മെസ്സേജ് സെൻറ്ററിൻ്റെ പ്രൈവറ്റ് കീ ഉപയോഗിച്ച് അതിനെ എൻക്രിപ്റ്റ് ചെയ്തു. ദാറ്റ് എൻക്രിപ്റ്റഡ് വാല്യൂ ഈസ് എന്താ പറയാം, നമ്മൾ ഡിജിറ്റൽ സിഗ്നേച്ചർ ജനറേഷൻ അൽഗോരിതത്തിലിട്ട് അവിടെ സിഗ്നേച്ചർ കിട്ടി, അത് മെസ്സേജുമായിട്ട് അപ്പൻഡ് ചെയ്തിട്ടാണ് നമ്മൾ അയക്കുന്നത്. രണ്ടാമത്തെ കേസ് നമുക്ക് മെസ്സേജിൽ നിന്ന് ഹാഷ് വാല്യൂ ജനറേറ്റ് ചെയ്യാം. അതിനെ ഹാഷിനെ എൻക്രിപ്റ്റ് ചെയ്ത് കിട്ടുന്ന ആ ഒരു ഇത് നമുക്ക് സിഗ്നേച്ചറായി യൂസ് ചെയ്തിട്ട് സിഗ്നേച്ചർ മെസ്സേജിൻ്റെ കൂടെ അപ്പൻഡ് ചെയ്ത് റിസീവറിലേക്ക് അയക്കാം. റിസീവറിൽ അത് ഹാഷ് വാല്യൂസ് കമ്പയർ ചെയ്തിട്ടാണ് അതിൻ്റെ വെരിഫിക്കേഷൻ നടത്തുന്നത്. ആക്ച്വലി ദിസ് ഇസ് ഡയറക്റ്റ് ഡിജിറ്റൽ സിഗ്നേച്ചർ. സെക്കൻഡ് മെക്കാനിസം എന്ന് പറയുന്നത് ആർബിട്രേറ്റഡ് ഡിജിറ്റൽ സിഗ്നേച്ചർ ആണ്. ആർബിട്രേറ്റഡ് ഡിജിറ്റൽ സിഗ്നേച്ചർ എന്ന് പറയുന്നത് വി ഹാവ് എ സെൻറ്റർ, റിസീവർ, അതിൻ്റെ ഇടയിലായിട്ട് ആരുണ്ട്, ഒരു തേർഡ് പാർട്ടി ഉണ്ട്. തേർഡ് പാർട്ടിക്ക് പറയുന്ന പേരാണ് ആർബിറ്റർ. ഓക്കെ, സോ arbitrated digital signature is by using three mechanisms. One is conventional encryption, in which arbiter sees the message. Conventional encryption നമ്മുടെ സിമെട്രിക് എൻക്രിപ്ഷൻ ഉപയോഗിച്ചിട്ട് നമുക്ക് ഡിജിറ്റൽ സിഗ്നേച്ചർ മെക്കാനിസം അപ്ലൈ ചെയ്യാം. ഇവിടെ ആർബിറ്ററിന് മെസ്സേജ് കാണാൻ പറ്റും. ദാറ്റ് ഇസ് ദ ഫസ്റ്റ് മെക്കാനിസം. This representation in figure, what we are seeing is the actual procedure that is behind the first method, conventional encryption. Arbiter sees the message. So here three communicating parties are there. One is X, that is the sender, and Y is that is the receiver. In between there is A. What is A? A is arbiter. Okay, so the communication is actually from sender to arbiter, and in next step arbiter to receiver. I hope you are clear. You have three communicating parties. One is X, another is Y. They are acting as a sender and the receiver, and in between there is another communicating party, that is arbiter, A. So we have two steps, main two steps. One is the communication is from sender to arbiter, and the other is from arbiter to receiver. You can see in the figure. Okay. Then what we are doing in first step is we have an original message. M, capital M. M is the original message. First you share the secret key between X and A. We are using conventional encryption or secret key encryption. Okay, the same key is used for encryption and decryption. That is actually conventional encryption. So first, in between the communicating parties, share a secret key. So in between X and A, what is the secret key? KXA. XA represents the secret key in between the sender and the arbiter. Okay, first we share the secret key in between X and A, that is KXA. Second, we take the hash of a message, H of M. You can see in the figure. Okay. Then M, capital M, the original message is appended with encrypted signature. Okay. Capital M, the original message is appended with encrypted signature. So M, two standing lines are there, that is appended operation or appending operation. So M is appended with, next, E of KXA. Encryption by using KXA is the key. What we are encrypting? ID of X appended with hash of M. So we are generating a hash of M. They are appended with the identifier of the sender. That is a unique value. Okay, that is ID of X. So first we share the secret key in between X and A. Then we are taking hash of M. That will be appended with the ID of X, unique identifier of X. Then we are encrypting the whole part to produce a signature by using KXA. Then what we are getting is the signature that will be appended with the original messages. That is the first step. And in the next step, that is a communication from arbiter to Y. You can use or you can share a secret key in between arbiter and the receiver, that is KAY. Okay, and what the procedure has happened in the next step is we are appending the unique identifier of the sender and the hash of messages along with the timestamp. Capital T stands for the timestamp. So append all the three, and by using XA you can encrypt the messages. Then again it is appended with the original messages. Then again it is appended with the ID of X. And the whole is encrypted by using KAY. You can see. And why we are using the timestamp? We have to ensure the time. Or we have to ensure if there is any delay or so for that we are using timestamp mechanism in between the arbiter and receiver. If there is any delay that has happened in arbiter or not. Okay, so this is the first arbitration mechanism, arbitrator digital signature, that is conventional encryption. So you can see the arbiter can see the messages, right? Because messages and append in first step you can see messages appended with the signature. So you can directly take the messages by this arbiter. So arbiter can see the messages. Clear? So what is the explanation of this figure is in this slide. You can go through it. Already I explained. And in next figure or next arbitration mechanism is you can use the conventional encryption or secret key mechanism, but the arbiter does not see the messages. The original messages that is sent by the sender is not getting into arbiter. So the arbiter does not see the messages. Okay. So you can see in figure That is, there are three communicating parties, X, A, and Y. So two steps are the main two steps, or main two communication has happened here. From X to A, sender to arbiter, and next is from arbiter to receiver. Okay. So from X to A, what we are doing is we are sharing three secret keys. One is in between center and the arbiter, and next is from arbiter to receiver, and the third secret key is by using center and the receiver. So XA is in between X and A, AY is in between A and Y, then XY is in between X and Y. So there are three secret keys are used here. So in first step, first encrypt the original messages by using XY key. Okay, then taking the hash. Then it is appended with the identifier of X. Then again encrypting by using XA. That is appended with encrypted format of the messages. Again it is appended with ID of X. So what is the output? That will not see any messages, original messages. So at the arbiter side, there will not see any original messages. Only it is in encrypted form. Clear? That is why this mechanism is known as conventional encryption without seeing the messages by the arbiter. Okay, that is the first step. And in the next step, it is a communication between arbiter and the receiver. So what we are doing is the same procedure. First, you are taking the encrypted format of the original messages by using XY, then taking the hash, appended with the timestamp and ID of X. Again, it is encrypted by using XA. Then it is appended with encrypted format of messages. Then it is appended with the ID of X. Again, it is encrypted by using the secret key between A and Y, that is EKY. So that is the second step. Okay, conventional encryption. Arbiter does not see the messages. Why it does not see the messages? Because the message is in an encrypted format. So this is the explanation. It actually provides some confidentiality. We are using timestamp to ensure the timing, or to ensure the delays happened or not. And the third mechanism is the public key encryption but the arbiter does not see the messages. So again, in this method also there are three communicating parties, X and Y, and you are using encrypted format of the messages. That is why the arbiter does not see the messages. Okay. So by using, or first step, it's a communication between the sender and the arbiter. So original message is taken, and by using the private key of the sender, encrypt. Then by using the public key of the receiver, again encrypt, appended with the ID. Again, the whole part is encrypted by using the private key of the sender, then appended with the ID of X. You can see the arbiter get an output or get a result, but it does not contain the original format of the messages. It's only in encrypted form. Okay, so actually the arbiter does not see the messages. Okay, and second step, you have a communication between arbiter and the receiver. Here also you are using a timestamp. Already I said that the timestamp mechanism is for proper time ordering. So we are encrypting the messages by using the private key of the sender, then appended with the timestamp. What we are getting is the output. Then again it is encrypted by using the public key of the receiver. Then it is appended with the ID of X. Then again the whole portion is encrypted by using the private key of the arbiter. Okay, so you have to study thoroughly all these three mechanisms, because the arbitrated digital signature is a very important digital signature mechanism. Why we are using all this mechanism is to provide the efficient security. Okay. So this is the encryption. You can go through it. And these are all about the digital signature mechanism. Okay. There are two mechanisms, direct digital signature and the arbitrated digital signature. Thank you.